The California Energy Commission online training series is funded in part by Louisiana Pacific, makers of TechShield radiant barriers.
It's no surprise that attics get so hot. Now this heat that strikes the roof ultimately makes it into the attic and then finally into the home, where it drives up your customers' energy bills and makes them a lot more uncomfortable. Well, radiant barriers can mitigate this heat flow. So let's go take a look at how they're installed and find out how they work. One of the easiest ways to install a radiant barrier is to install it when you install the roof deck. This product, for example, has foil laminated to a piece of OSB. That way, when you put down your 4x8 sheets of roof deck, your radiant barrier is already in place. Joining me today is Bob Lowe, who is product specialist at Louisiana Pacific. Now, I understand that this product reduces radiant gain by as much as 97%.
That's correct. It has an aluminum foil applied to the product with a craft layer intermediary to bond it to the OSB, and it reflects back up into the roof, into the shingles or tiles, 95% of the radiant energy that hits the roof.
So basically, the way these products work, if we think about how much heat from the sun hits the roof, it's a lot. It's like 250 BTUs a square foot. That energy gets absorbed by the roof deck and then gets re-radiated into the attic. So how much cooler is an attic going to be?
An attic will be about 30 degrees cooler at maximum with a radiant barrier applied to the OSB.
Now, what kind of energy savings do you think we're looking at here?
Well, we've done a test with side-by-side structures that determined that we had an 8.4% energy savings in kilowatt hours throughout the entire year with radiant barriers.
Now, at first glance, you look at this and you say to yourself, why is the shiny side down? That's because a product that has a high reflectivity also has a low emissivity. It just can't give off its energy very well, right?
Yeah, that's correct. It's simple physics. It reflects back into the mass, the greatest mass that it's in proximity with.
And the reason why we wouldn't want to put this face down in the attic like this is because it would get covered with dust and
Right.
It wouldn't work as well.
That is correct.
Now, you have a demo here that you can show us kind of how this product works. Is that right?
That's right. We have two sides with a heat source replicating the sun, a radiant source. And on one side we have TechShield, and on the other just a standard OSB. And the difference in chambers beneath it, replicating an attic, are vary from about 90 degrees up to about 120 without the product. So there's a substantial decrease in ambient temperature in the attic cavity, which results in a much less, a lower temperature environment for HVAC equipment to be to work in.
And that's an important thing, because when you figure that the average home might have as much as 25 cents out of every dollar being lost through leaks in the ductwork, if you've got an air handler, an air conditioner up in a 140-degree attic, that's going to basically suck in that hot air in through the duct leaks and going to make it a lot harder for your air conditioner to work.
That's right.
Well, Bob, product durability is always an issue, always a concern. Do I ever have to worry about this stuff coming apart?
No, the board, the aluminum itself is glued to a craft paper surface, which is in turn glued to the board. And it has a 20-year warranty. The board itself has a 20-year warranty against delamination, and it is warranted for that period of time to act as a radiant barrier.
Well, this is a pretty neat product, and then I never have to worry about installing it. It goes up with the roof deck, a lot less labor. Whether you comply to the code using the prescriptive method or the performance method, radiant barriers make a lot of sense. They're very cost-effective to install. They'll make your attics a lot cooler, which means your air conditioners are going to run less. Also, your home's going to be a lot more marketable, and they're going to be much more energy efficient.